because she lives with it. Where I'm the one who will go out back to like mow the yard and come in like 2 hours later and no, the yard's just not even mowed. Like I will just like decide instead to build a patio. And she's like, really? I just needed the yard mowed. Do what? Oh, it looks way better. My ideas are way better, but you know, she's in charge. So yes, Leilani? Any of the what? I'll show you how to get there. Okay? Did you go to the library, the list of playlists, and look at all the unit numbers? Say what, Leilani? And you weren't at the right site. I'll show you how to get there. Christopher, you're learning pre-algebra. This is 8th grade pre-algebra. You are in no way doing what they do in Unit 4. This is going to help you better understand Unit 4 when we get there next year. Okay? So as I was saying before, slope represents a mathematical measurement of the slant of a line. And a line can look a bunch of different ways. A line can look a bunch of different ways. There are large slopes, there are small slopes, there are no slopes. There are slopes you cannot measure at all. Okay? There are lots of different measurements of slope. There are positive slopes and negative slopes. Positive slopes and negative slopes. Slope is a mathematical measurement. Like I was saying before, you can't really measure the slant of a line. If I give you a line, you can measure the slope of the line, but what it really means is you're actually measuring two different things. Slope is a ratio. Slope is a ratio. Slope is a ratio of. Yeah. Slope is the. Yes, thank you. Thank you very much. Slope. Thank you. Slope is the measurement. I'm recording, so I'm going to say nothing. It's like, but if you want to go home and listen to this, we'll be in the middle of a slope conversation going, did you say something? Oh my gosh, you're the best ever. I got a new pair of shoes. Or something. I don't even know. Scared me. The only thing that made me feel good, is I knew if she was going to start like stabbing people, that Hatai and Jackson were going to get hit long before I got hit. So I was feeling reasonably certain about my ability to sneak out the bathroom door and get out of here safely. Not that I wouldn't protect you with my life. Right? You go, kill him first. Okay. So, slope is a ratio. Slope is a ratio. So what you really end up having to do is you have to measure two things to find the slope. You have to measure two things to find the slope. You have to measure how fast a line is going up, and you have to put that over how fast a line is going over. No way. Yes. You have to measure how fast a line is rising, and then you have to measure how fast it is running from point to point, and then make that a fraction or a ratio. You'll hear it referred to as rise over run. You'll hear it referred to as rise over run. It's not. And once you get that, then you essentially have the slope. And all you have to do at that point is simply simplify that slope. So I'll show you a quick example. So say we have a coordinate grid, and we have a line, So let me see if I can get this exact. It's always somewhat complicated. So let's go here, and I do, but I just think she probably should have not screened it. so that's just me. Okay. So say I have this line. Say I have this line. And I'm going to measure the slope of the line. All you really have to do in order to measure the slope of a line is first you need to find 2 points. Now the points need to be good points. Okay? In other words, you couldn't say I'm going to measure the slope between here and here, because you cannot necessarily measure the rise or the run. So what you end up having to do instead is pick 2 good points that cross at exact places. Like I could pick there and I could pick there. Those are 2 good points. They cross at exact places. Yes. I'm sorry? Yeah, that's what I'm saying. They have to be good points. They have to cross at integer points. They need to be exact places. You don't understand what integer is, Bennett? Because if so, you're going to have trouble with slope. Okay. So after that, after you pick your 2 good points, and they can be any 2 good points that you want, we are going to first measure the rise, how fast the line is rising, and then we are going to measure the run, how fast it is going over. How we get from one point to the next one that we picked, rise, I just need you to sit and soak, okay? How fast it rises over how much it runs. Now, when you're counting, I need you to understand very carefully that when you're counting on a coordinate grid, you do not count where you begin. Where you begin is your 0. If I'm counting steps, I don't go like this, 1, 2. I have not taken 2 steps, I've only taken 1. You count on the step, 1, 2. So when I'm counting from here to here, I would go 1, 2, 3, 4, 5. My rise is 5. And then I would count my run from here, 1, 2, 3, 4, 5, 6. My run is 6. Do you have a question? Okay. I'm saying that anywhere you begin and you are going to start counting, your beginning point is indeed 0. Nolan? Yes, it always creates a right angle. Now, what that means is if we think about slope as rise over run, then we have a slope of 5/6. That's your slope. Now, the interesting thing is, on a line, which is something that is straight and no matter what, then the slope is constant. I'll get to you in just a moment. So say instead we had picked, let's see, here, I think. Nope, that's not a good place. It looks like it's good, but it's not. So it's right here. That's a good place. Because it crosses at an exact place. See how at this grid, it crosses exactly. You need to pick a good crossing place that is an exact ordered pair. That is an exact ordered pair. That's what I'm talking about. Do you know what decimal it is? Then do you think it could be a decimal? Then right. Okay? Now, say we picked this point. Let me erase that. Say we picked this place and we picked this place because we didn't see that one or whatever. And we measured rise over run. Well, again, we would measure the rise, which is this. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we would measure the run, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then when we measure the rise over the run, we end up with 10/12, which simplifies to 5/6. And that is because, and then Terry, I'll get to your question, that is because for a line, slope must be constant. The slope never changes. If you think about, if a slope changes, you have a line going along, all of a sudden the slope changes, it's not a line anymore. It's non-linear. Tara, what was your question? Absolutely there will be. She said, is there ever going to be a larger number over a smaller number? And there is. If you think about measuring slope, if I'm measuring the slope between this point and this point, my rise is going to be much greater than my run. Now, when you give me slope, and then Jonah, I'll get to your question, it must always be in the form of a simplified improper fraction. Never give me a mixed number for slope, because I want you thinking about slope as rise and run. Jonah? Nope. Well, sort of you can, yeah. And we'll get to that in just a second. Christopher? Absolutely. Don't ever ask that again. Ever. Always simplify fractions. Always. A ratio and a fraction. Okay, you're killing me. Okay. Gavin. Always. That's very, yes. The rise will always be the numerator, and there you fell into the very first thing that gets kids every time. The rise will always be the numerator, and the run will always be the denominator. By the way, one other quick thing, and then Alex, I'll get to your question. You also want to be very careful about the scale of your graph. You want to be very careful about the scale of your graph, and I'll show you what I mean by that. What if you had a coordinate grid where the x-axis was counting by 2s and the y-axis was counting by 5s? So you need to be aware of that when you're measuring rise and run, the scale of the graph absolutely matters. Okay? Wait a minute, Alex. Absolutely you can. And I'll show you one in just a moment. Labib? Who else had a question? Tara? It's alphabetical. That's exactly right. And there's another way to remember it, and I'm going to tell you about that one in just a second. Jonah? No. Well, I'm not done moving it, so probably not. Okay. Now, Alex asked an important question. He said, can slope ever be negative? No, that's not true in any way, shape, or form. Okay. Well, yeah, but he said always, and that would not be true. Absolutely. So we end up looking for two ordered pairs, 2 points where it crosses at an exact place, and I have them there and there. And again, just like you read on a page from the left to the right, we would start at the lefternmost point because we are going to rise first. Now, you can either rise up or you can rise down. And to get, you would, on this case, how do you get from here to here? Let's see, 1, 2, 3, 4, but you went down, therefore it's -4. No. I know what you're saying, I'm telling you no. Okay. No, I'll hear him out because he thinks. No. Are we good now? Because I already knew what you were asking. That's why I was answering in advance. Okay. What Jackson was asking is basically this way. If you're reading from the left to the right, what it basically means is that the run number will always be positive because you're always going from the left to the right. And on a number line, When you're going from the left to the right, it's always positive. Which, if you'll think about it, so what's the slope for this? Well, the slope is, again, rise over run, which in this case is -4/2. Now, before I simplify that, I want you to understand, do you remember when I told you that you are only allowed to give me a negative in the numerator? That's why. It will never be in the denominator if you did it properly. Okay, go ahead. There's no such thing as a curved line. Guys, so that you understand, and this is one of those things where you really do need to understand that mathematically speaking, there is no such thing as a curved line. A line by definition has a constant slope and goes on forever. The only way you have a constant slope is if it's straight. If it is curved, when you get into upper level mathematics, there are terms to describe curves, parabolas, hyperbolas, all sorts of different descriptions with regard to those things. Alex? Because the expectation is that if you're in upper level mathematics, you can make a whole number into a fraction instantly. How do you always make a whole number into a fraction? Put it over 1. So when you're thinking about something, if I tell you guys, if I tell you that the slope of a line is -5, where I want you to end up by the end of this week is I want you to be able to create, Jackson and Brendan, I can send you out of the room if y'all want to go ahead and do something else somewhere else. Jackson, I'm not kidding. You need to be able to create a mental image of what a line looks like based solely on the slope. In this case, based off the fact that it has a slope of -5, you kind of put it in the form of a fraction, which -5 becomes -5/1, which then means that if you start at this point and you're going to the next point, to get to the next point, you will go down 5/1. You will go down 5/1, and then down 5, and then over 1, and then down 5, and then over 1, which means that your mental picture of this line should be that it's very steep and it is decreasing. If I tell you that something, no, you can wait. If I tell you that something has a slope of 1/4, then in your head, you think about it as rise over run. So that means from a point, it's going up 1/4, up 1/4, which means this line is a very flat increasing line, so it looks something like that. And that is critically important to your understanding of algebra. Cameron? We're going to get to that in just a second. That's a good question. Claire? Yes, and we don't know why, but it is. Anytime you see the letter M, they're talking about slope. And in fact, if you look on the formula sheets for algebra or 8th grade, you'll see it referred to as M. Okay? Gavin?
In this unit, will we have to, like, draw and like,
You might on a test. Okay? Any questions on how to find slope from a graph? Rise over run, rise over run, rise over run. Okay, so once we get that, then question was asked about how we deal with slopes, how we deal with lines that are flat or straight up and down. So we understand that any slope that looks like this and is increasing from the left to the right is a positive sloped line. No matter what its steepness is, if it's increasing from the left to the right, it's a positive sloped line. If it is decreasing from the left to the right, no matter what its steepness is, it is a negative sloped line. The reason that is if you think about the points, you will always have to go down and then over On a negative slope line, you will have to go up and over on a positive slope line, which leaves vertical and horizontal lines. Vertical and horizontal lines are one of two slopes. They are either considered to be undefined might be a reason grades are what they are, so let's pay attention. Got it? Good. Slopes are either undefined or there are zero slopes when they're vertical and horizontal. There's a trick to remember that I teach my kids, and it's the easiest trick in the world. So remember, slopes are either undefined or they're zero. They're either undefined or they're zero. Undefined or zero. Undefined slopes are vertical, and zero slopes are horizontal. If I say, what is the slope of this line? You ask yourself, can I make a Z out of that line, or can I make a U out of that line? I can make a Z out of this line, therefore it's a zero slope. If you draw a vertical line, you ask yourself, what can you make out of that line? U or Z, you can only make a U, therefore a vertical line is an undefined slope. Yes, sir. What? Because an I has a vertical and a horizontal line. That would make it a little bit complicated. Okay. Or how about you just go with my trick since I've been teaching it a little longer than you have. Just throwing it out there. And what does I stand for? Why not make it an E? Okay. What? Okay, here's the reason that is. I want you to listen carefully. If you think about a horizontal line, if you're measuring the rise over the run, say you pick 2 points. Say we pick 2 points on a horizontal line. If I'm going to measure the rise from one point to the next, what do I end up with? 0. You end up with 0 in the numerator, and the run is whatever that run is. Hold, just listen. That means if you do mathematically 0 divided by 8, the calculator will tell you it's 0. Now, on a vertical line, if you're measuring the rise over the run, no matter what the rise is, say it's 8, what is the run? Anything divided by 0 is undefined. It's a non-real number. Okay? But I like the trick easier. Okay? You will eventually need to simply memorize that vertical lines have an undefined slope and that horizontal lines have a 0 slope. Oh, yeah. Uh-huh. You'll need to know it for your homework. Mm-hmm. Yeah, you'll need to know this in like 15 minutes. Christopher. What does algebra do for slope? I probably will wait until you get to algebra and then talk to you about it. Okay? Now, we also need to be able to find slope from a table. Now, when you're finding slope from a table, you can simply take a coordinate grid and graph the points and find the rise over the run. But there are times where that is not a reasonable way to solve. Jackson, what's your question? No, I don't need a comment. I just need questions. There are times where it is not reasonable, and I'll show you what I'm talking about. So let's do... It is. Okay. So if I were to give you this table and say I need you to find the slope, then it's not necessarily reasonable for you to expect to be able to find a coordinate grid whereby you can graph those points and measure the rise over the run. So there's something, I need nothing but just listening. There's something else that we use. Now, to find the measure of slope from a graph, we measure rise over run. Which variable represents the rise of a line, Jaden? The y does. The y-axis represents the height of a function, the measure of its rise. So here's what you can do. You can ask yourself, how do I get from negative 25 to negative 24 on a number line? Wait. You add 1. If you think about on a number line, to get from negative 25 to negative 24, you would add 1. And how do you get from 79 to 76? You subtract 3. Now, you can write what's called the change in y over the change in x. Delta y over delta x. And then you simply write it negative 3 over 1, which means your slope in this table is negative 3. Let's try this. How do you get from negative 25 to negative 19 on a number line? You add 6. How do you get from 79 to 61? Minus 18. And if you set up change in y over change in x, you get negative 18 over 6, which is negative 3. Again, because slope is constant. The measure of that slope must always be constant. If you ever get different numbers, then you did something wrong, or it's nonlinear. Alex? I never said it was proportional. I haven't said the word proportional one time during this slope discussion. Because in order to measure slope, I only need one thing. I need a line. I don't care where it crosses the y-axis. Well, a vertical line doesn't mean you can't measure the slope. It'd be undefined, yes? By the way, an undefined line is the only line that doesn't ever cross the y-axis unless it is the y-axis. And a horizontal line never crosses the x-axis unless it is the x-axis. It crosses it a lot. Yes? Jonah, you better not have a question when we get to homework. I would right now use what you have, but eventually you may end up wanting to extend it because the where it crosses the y-axis does indeed matter eventually. It'll matter tomorrow. It doesn't matter today. So here's what I'm going to ask you to do. Bennett? Because I want the slope expressed as either a fraction or a whole number. I just can't have it as a mixed number. Okay? And the expectation, again, is if I give you slope as a whole number, that you can create a mental image as to what that slope looks like, because you just take the whole number, put it over 1, think of it as rise over run. Jackson? I'd rather have a whole number if it is a whole number. I'd rather have a whole number if it is a whole number. Okay? When you're describing lines, you will describe them as either increasing or decreasing and steep or flat or horizontal and vertical. Okay? You will either describe lines as horizontal and vertical, which doesn't happen very often, or increasing and decreasing and steep or flat. How do you determine steep lines have what in common as far as their slope is concerned? Steep lines have what in common regarding their slope, Labib? Their rise is greater than their run. If a line has a rise that is more than the run, it is considered a steep line. If the rise is less than the run, it is considered a flat line. Okay? You would say it is neither flat nor steep. It actually has a name, but we're not getting involved in that first day. Okay? Bennett. Yep. That's why I said I want slope as a simplified improper fraction. Okay? Yeah. Any questions on all that? So here's what we've got to do today. You have classwork and homework. Now, both pages, both the classwork and the homework are only one page. Okay? One side, one page. Now, what I want you to do is I want to make sure that you take your time. I want you to go through the classwork. I want you to answer every one yourself. Okay? If y'all want to have a discussion every now and again, that's fine. But if I see you constantly going to someone else, you don't get it, and you need to get it before you walk in here tomorrow. When you are done with your classwork, you're simply going to check it against these answer keys, which I'll put at the front table and over here. Don't take them back to your desk. You finish it, you walk up, you check your answers. If you get something wrong, figure out why. If you can't figure out why, you come talk to me so that we can discuss it. Once you're done with the classwork, you may throw it in the recycle bin, pick up a homework sheet, which is on the desk next to mine. That is what is due tomorrow. Any questions on what we're doing today? All right. Don't forget your homework from yesterday as well, by the way, please.